Today, we will explore the groundbreaking discoveries of the James Webb Space Telescope and how it unveils the mysteries of the universe. New discoveries of the James Webb Space Telescope. Space exploration continues to reveal the secrets of the universe with new discoveries every day. One of the most important tools in these explorations is NASA's James Webb Space Telescope, JWST, launched in 2021 and fully operational by 2022. This telescope is one of the most advanced observatories, allowing us to peer into the deepest regions of the universe. Today, we will discuss one of James Webb's latest discoveries, the light echo of a supernova and the three-dimensional mapping of gas and dust, clouds in space. Additionally, we will take a look at some of the other groundbreaking discoveries the telescope has made. James Webb Space Telescope, unveiling the mysteries of the universe, representing humanity's endless curiosity and its relentless pursuit of uncovering the universe's deepest secrets. The James Webb Space Telescope, JWST, has exceeded astronomers' expectations in its first year of operation, mesmerizing the world with its stunning images. Breathtaking images from the James Webb Space Telescope. The journey that began with the launch of the Hubble Space Telescope in 1990 continues today with the James Webb Space Telescope, Webb, which is much larger than Hubble, and was launched into space on December the 25th, 2021, aboard an Ariane 5 rocket from French Guiana. Thanks to this telescope, we can observe what Hubble has seen in much greater detail and find definitive answers to fundamental questions about the nature of the universe. A collaborative effort between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. Webb was sent into space as a powerful tool to investigate celestial objects that have formed since the beginning of the universe. Now let's start with the most frequently asked question: the astonishing features of the James Webb Space Telescope. The James Webb Space Telescope, JWST, plays a crucial role in observational astronomy by providing unprecedented high-resolution images and spectroscopy of distant celestial objects. Its primary mirror, with a diameter of 6.5 meters, is nearly 100 times larger than the Hubble Space Telescope's primary mirror, enabling it to capture far more detailed images. In terms of observational capabilities, JWST can capture breathtaking images of distant galaxies, nebulae, and other celestial bodies that current telescopes cannot reach. This capability allows us to study the formation of stars and planets, as well as provide detailed views of the oldest galaxies in the universe. On July 12, 2022, the first data from James Webb reached Earth. Now, let's examine these groundbreaking discoveries one by one. First data: Deep Field, SMA CS 0723, the deepest infrared image of the universe ever taken. The first data received became the most detailed infrared image ever taken of the most distant parts of the universe. This stunningly detailed image of the SMACS 0723 galaxy cluster made history as the telescope's first deep field observation. The telescope's advanced infrared cameras allowed us to see thousands of galaxies within the cluster with incredible clarity. Although the image above captures a massive region in the vastness of our universe, it represents an area no larger than a tiny grain of sand in a desert. Moreover, this image actually shows the cluster as it appeared 4.6 billion years ago. This is because the distance of a star or celestial object in light years corresponds to how far back in time we see it from Earth. For example, the Sun is about 150 million kilometers away from Earth, and due to its light year distance, every time we look at the Sun, we are actually seeing it as it was 8.3 minutes ago. The massive gravity of the SMACS 0723 galaxy cluster acts as a gravitational lens, bending and magnifying the light from even more distant galaxies. This phenomenon is known as gravitational lensing. Due to this effect, you can observe elongated galaxies around the edges of the cluster. As Webb continues its search for the oldest galaxies in the universe, scientists will soon uncover more about the masses, ages, histories, and compositions of galaxies, thanks to this groundbreaking telescope. Data 2. Exoplanet W, ASP 96b, the steamy atmosphere of an exoplanet. Webb also collects information about exoplanets studied by participants in our Planet Hunters educational program. These studies play a crucial role in exploring the atmospheres of distant exoplanets and searching for planets with potential conditions for life. One of the most groundbreaking discoveries made by the James Webb Space Telescope was its detailed analysis of the atmosphere of an exoplanet, WASP 96b, located approximately 1,150 light-years away in the Phoenix constellation. This hot gas giant orbits its star every 3.4 days. Unlike any planet in our solar system, WASP 96b is classified as a hot Jupiter, meaning it has extremely high temperatures due to its close proximity to its host star. Thanks to Webb's advanced infrared observation capabilities, this planet's atmosphere has been studied in unprecedented detail. Webb's powerful spectroscopic capabilities allowed scientists to detect the presence of water vapor in the atmosphere of WASP 96b. This discovery marks one of the most detailed atmospheric analyses of an exoplanet ever conducted. Using the Near-Infrared Imager and Slitless Spectrograph, NIRIS, the telescope captured a transmission spectrum, revealing how the planet's atmosphere filters starlight, leading to the clear detection of water vapor signatures. The spectral data showed significant amounts of moisture in the atmosphere, despite the planet's extreme temperatures. Additionally, scientists detected clouds and haze, which was a surprising discovery since previous studies suggested the planet had a completely cloudless atmosphere. This finding suggests that WASP 96b's atmosphere is far more complex than initially believed. This observation marks a major breakthrough in exoplanet research. By analyzing the atmospheric compositions of distant planets, Webb will help scientists determine whether other worlds might have conditions suitable for life. As the telescope continues its mission, researchers anticipate even more discoveries about exoplanet atmospheres, bringing us closer to answering one of the greatest mysteries of the universe. Are we alone? Third data, stellar death, Southern Ring Nebula, NGC 3132, a dying star's final performance. The Southern Ring Nebula, which was also photographed by the Hubble Space Telescope in 1998, is a nebula formed by the explosion of a medium-mass star. For millions of years, the dim star at the center of this image has been shedding gas and dust in all directions as it reaches the end of its life. However, these gases and dust may eventually come together to form one or more planets within the nebula. Using 2 cameras on Webb, the latest image of this nebula, officially known as the Southern Ring Nebula and cataloged as NGC 3132, was captured at a distance of approximately 2,500 light-years. Interacting Galaxies, Stephan's Quintet. Webb's powerful infrared vision and extremely high-resolution cameras reveal details in this galaxy group that were previously unseen. The image is adorned with clusters of millions of young glowing stars and starburst regions where new star formation is actively taking place. Although it is called a quintet, only 4 of these galaxies are actually interacting with each other. The 5th and leftmost galaxy is closer to us and has no interaction with the others. The leftmost galaxy is located just 40 million light-years away, while the other 4 are a staggering 290 million light-years from us. This massive mosaic, large enough to cover about 1/5 of the Moon's diameter, is the largest image Webb has created to date. It contains over 150 million pixels and was assembled from nearly 1,000 separate image files. With this photograph, Webb has provided a new perspective on how galactic interactions in the early universe have shaped the evolution of galaxies. 5th data, star formation, region NGC 3324 in the Carina Nebula. This breathtaking landscape, adorned with shimmering stars and resembling mountains and valleys, is actually a region known as NGC 3324, located near the Carina Nebula, where young stars are formed, captured in infrared light by the James Webb Space Telescope. This image has revealed previously unseen star-forming regions for the first time. Webb's magnificent photograph, dubbed the Cosmic Cliffs, may look like a landscape image featuring steep mountains on Earth, but in reality, these are the boundaries of the vast cavity within NGC 3324. The areas that appear as ridges in the image are approximately 7 light-years high. The intense ultraviolet radiation and stellar winds from massive, hot, young stars above the depicted region have sculpted the indentation visible in the left center part of the image. As we mentioned earlier, if we think of the universe as all the sand on Earth's beaches, our current discoveries might be no more than a single mineral molecule within a grain of sand. In the future, we will learn more, and we will be even more amazed. Conclusion and closing. The James Webb Space Telescope is a crucial tool for understanding the past, present, and future of the universe. From supernova light echoes to exoplanet atmospheres, from the evolution of black holes to the processes of star formation, it continues to make groundbreaking discoveries across various fields. In the coming years, we eagerly await the new insights JWST will bring. What secrets lie hidden in the depths of the universe? Will we find traces of extraterrestrial life? What will we learn about black holes and the first stars? Stay with us as we continue to explore the answers to these big questions.